Some common matrices that you may be interested in creating with R, for instance, could be the identity matrix. Again, this is interesting for those of you who want to experiment with linear algebra notions. So for example, say you want to create the 3 by 3 identity matrix in algebra, you would write something like this. So the identity matrix 3 times 3. How do we do this in R? Let me call ident. For identity, you could give it a different name. And here's where we use a useful function called diag or diagonal, specifying that on the diagonal, we want to be all elements 1, and then just the dimensions and row equals 3 and column equals 3. This can be more compactly written as diag 1, 3, 3. It is exactly the same thing, or even as diag 1, 3, and again, R will always create a square diagonal matrix. Another possibility, for instance, is when you want to have a matrix full of ones. So let's say I want to create a ones matrix. You could give it a different name. And again, take advantage of recycling behavior in R. So all of them 1. For example, 5 rows, 5 columns. So this will effectively give you a matrix all full of ones with 5 rows and 5 columns, something like this. One more column, there we go, right? So something like this, everything full of ones. Another example could be creating a matrix full of zeros. So I could call it zeros. Let's say I want the 3 by 3 matrix full of zeros. It doesn't have to be a square by having the same number of rows as columns, but let me take this example. You take advantage of recycling, just specifying 0, and then 3 rows, 3 columns. So R will give you a matrix, in this case 3 by 3, full of zeros. Some related functions about matrices in R. The main function matrix. There is the dimensions functions. Typically, we use this to inspect the dimensions, the number of rows and columns of a matrix. You could also check individually the number of rows with n row, the number of columns with n col. I told you R matrices. Often you may want to provide names for rows or inspect what are the names of rows. So there is the row names function. You also have col names function, very useful functions. You could also check the entire length of a function. This will give you the total number of elements in a function. Of course, you could also use the type of function to check the data type of a matrix. There is the explicit coercion function as.matrix and its sibling function is.matrix to check whether an input object is a matrix or not. And then here from the more algebraic point of view, and specifically the linear matrix algebra point of view, there is a long list of functions available in R. I just mentioned the diagonal function to either extract the elements in the diagonal, or you could also use it to specify a diagonal matrix. So this can be used for both purposes. There is the t lowercase t function. This allows you to transpose the elements of a matrix. There is a bunch of operators. So say you have a matrix A and a matrix B of conformable arguments, conformable dimensions, then you could add them with plus. You could also use subtraction. You could also take the multiplication operator, not to do matrix multiplication, but just to do element-wise multiplication. And again, you could do division, element-wise division. This is not a matrix division operation, that doesn't exist. But again, you could use the typical mathematical operators. There is the solve function. This is a generic solver, typically to get the inverse of a square matrix. So this will give you the inverse. There are more fancy, sophisticated functions that allow you to deal with certain problematic numeric calculation issues, but I'm just going to show you solve. There's also DET for determinant, again, of a square function A. So this will give you the determinant. We have the eigen function. This will give you the eigenvalue decomposition of a square matrix. This is, again, useful for those of you who have taken linear or matrix algebra. There is also SVD that will give you the singular value decomposition. SVD, very useful in matrix algebra. Other decompositions, there is the function QR that will give you the QR decomposition. I'm just going to abbreviate it like this. There is the CHOL, CHOL. It will give you the Cholesky decomposition, also very interesting. And again, each of these functions, each of these decomposition functions will come with a set of sibling functions. Also useful could be extract the upper diagonal elements, also the lower diagonal or lower triangular elements. So this is the upper and lower triangular elements, again, to extract or to set them. You also have cross product, very interesting function if you want to do some sort of cross product or its transposed version of it. There is the norm function. This calculates matrix norms. And of course, if you want to multiply matrices with the matrix product, the matrix multiplication, the function that does that has this syntax. It's a binary operator. You need a percent symbol on both sides, to the left and to the right. And then in between them, the asterisk that indicates plain multiplication. So this will be the matrix product or matrix multiplication operator. Again, be careful because the dimensions of A and B have to be conformable. So this is an important condition. Dimensions must be conformable. Otherwise, R will give you an error. There is the very famous apply function. This actually corresponds to a family of apply functions, but the main one is called with the same name, the apply function in lowercase letter. What you provide inside parentheses is a R array, typically, again, not always, but typically this is going to be a matrix, two-dimensional array. And then you specify an index value and a function and possibly more arguments. So we may come back to talk about this family of methods, but I just want to introduce this to you right now that we are talking about matrices. This index, when the input is a matrix, 1 corresponds to rows, number 2 corresponds to columns. And then function, this could be the name of a function. For example, the mean or the median, or you could also specify your own function. And let me give you an example. Again, just in pictures, just to give you the idea. So say you have a matrix with, I don't know, let's say we have 5 rows and 3 columns. And imagine that what you want to obtain is you want to get the mean of all the elements in the first column. So you would like to get mean of first column. Same idea, you would like to get the mean of all the elements in the second column. as well as the mean of all the elements in the third column. So this can easily be achieved with apply. And again, let's assume that this guy, it's called X. So you would tell R, hey, please take X, my matrix X, and I want you to apply to all the columns. Again, index 2 means columns. Apply by column or to all the columns the mean function. And this will calculate the mean of the first column, the mean of the second, the mean of the third one. If what you want to do instead is calculate mean by rows, then you would have to just change the index from 2 to 1. And then let's say it's the same function mean, and this will calculate the mean of all the rows.